Hey students, jumping into the MCs from 13-2. If you take a look at the list, it's 1, 3 to 4, 6 to 7, and then a couple singles. So we'll do 1, 3 to 4. Mid segments of a triangle divided into 4 smaller triangles. Why do they all have equal area? And what's the ratio of the perimeter is smaller to the perimeter of the original? And again, this goes back into the scale factors. So take a look at that. 3 and 4. So 3 and 4, a 10-inch diameter pizza costs $10. How much should the 20-inch pizza cost? Again, a lot of people would say, hey, if you double the diameter, you should just double the cost. But think about it. Think about that with the scale ratios. Number 4, explain how the dissection of this drawing can be used to determine a formula for the area of the triangle. So notice what it looks like they did. They cut the top off and then moved it down on the side to create a parallelogram. So now what's the area of a parallelogram? Use that maybe to determine what is the area of that triangle originally. Again, really cool way to do things is to kind of dissect it into shapes that you know. Okay, we'll do 6, 7, and then 11. So 6, the length of a rectangle is increased by 10%. The width is decreased by 10%. Is the area changed? If so, does it go up or down? This ties back into what we did in prior chapters. And I said it's going to keep coming. Here it is yet again. So this goes back into chapter 7. So I'll put chapter 7 next to that. And remember, instead of trying to do the add on 10%, please turn these into factors. If something goes up by 10%, you multiply by 1.1 or 1.10 if you want to think of it that way. If it goes down by 20%, you multiply by 0.80. I don't know why I wrote 88. That right there is down 20%. This right here is up 10%. Keep them as multiplication because it will be easier to solve problems with multiplication. And this ties into the example that I showed in the first video where I said, hey, my trapezoid, I create a carbon copy so that I get a B2 here and a B1 here, and then it becomes a parallelogram. Use that to come up with the formula. And again, like I said, I like that way better than I do the way that they showed in the textbook. Then we got 11, 14, and 19. So I need to go to the next page. Question 11, in the following triangle, AB is 10, 6, and 8. And CD is the height. Find the area of the triangle and find CD. Now, the reason they're telling you can do it when you don't have all the information for the height is because of what they're giving you here. So this is the height. CD is the height. And you actually could say, because it does ask you to find CD, what is the height of this one? But there is an approach that was given in the book to finding the area using Heron's formula. And I think, let me delete here to go back and just kind of show that to you if you're doing question 11. There is an approach that allows you to find this quickly. I don't think I did it. No, I did not use it here. They did not use it here. So I don't think it was in the homework section. Oh, here it is. So it's listed right here. So the area, it is in the homework, is in part A. And so there wasn't a way for me to call it out, but question 27 in part A, and it shows here's how you can find the formula if you know just the 3 sides. So if you know all 3 sides, that's how you can find the formula. Now, if you go back to the homework, so that's using all 3 sides, you can absolutely do that. But let me jump back over here. What was it? 7, I think. No, one more. So the other way to find the area here that can get a little interesting to students are like, wait a minute, what? Is because this is a right triangle here. So thinking of the base here, then the height is what's perpendicular to it. So you actually can use what's in there. You don't need to use just all 3 sides, but some students sometimes say, how do I do it with just all 3 sides? You can do it using Heron's formula. But here you could find it slightly differently. And if you need to, and some students have said that this helps, redraw the triangle this way. It shouldn't matter, but to some students, this works better to see which one is a base and which one is a height. Got to get to a place where we don't need to do that. But again, if this is helpful for you, go ahead and draw it that way. Okay. There's 18, and I think I said 14, 19, and 21. So I picked a couple of questions from the classroom as well. John claimed he had a garden twice as large as Asher's. Let's see here. Asher's, it measured 15 by 30. When they visited John's, it was 18 by 50. And Asher claimed it could not be twice as large since neither the length nor the width was twice as large. How do you explain the misconception? So again, thinking about doubling the area, is that the same as doubling the length? Okay, so there's my hint on that one. And up here, 19, Ori claims to have found the area of a parallelogram, and you just multiply the lengths. Perfect. What would you tell him? Is he correct that this is indeed the area, or what would you say based on what you can see in this picture? And number 20, we found the area of a kite. A student wants to know, can we do it for any shape where the know how to prove the same formula works for any quadrilateral whose diagonals are perpendicular to each other? Okay, so these diagonals are perpendicular to each other. They are not going to be perpendicular and bisect, which means this, if you try to take this little piece out right here and kind of slide it up, it's not going to make the great big triangle that we saw when we were dealing with a kite. But the formula still may work perfectly well. So if you need a hint, perhaps a hint could be, why don't we use triangles? So can we find the area of 4 triangles, or in this case, maybe 2 triangles are all you need, and you might be able to prove the exact same thing. So give that a shot on number 21. That would be the last one of the MCs for this section. I hope that was helpful. Again, if you have questions, please let me know. I can make other videos for you. I can also meet with you in person on campus or online. All right, that does it for now. Off you go.